Good morning, good morning, good morning. How's everyone doing today? I see we have Rand here, Noelia, Alahurani is here. Who else do we have in the audience today? I'd like to thank everybody for coming. It is Wednesday morning of week 2, and we have now completed the first 3 chapters of this semester's of the textbook this semester. I hope everybody's having a good summer and Psych 150 is going well for you. Ala, don't worry. I see you couldn't attend the last 2 classes because you were traveling to go overseas. I am glad you are back. Where did you say you went? I think you told me last week, but I forgot. Did you go back to Jordan it was? I forget where you went. I'm so jealous that you were able to go overseas and have all that fun. I'm really looking forward to traveling overseas when they lift the coronavirus restrictions. Ebony Sampy, good morning to you too. Corals, good morning to you. Yep, Jordan, you lucky dog. I guess is that where you're from, Ala? Go ahead and type in the chat bar. I sent around a Kahoot yesterday, the second Kahoot, Sleeping Beauty. Thank you to all of you who participated in that Kahoot. It'll prepare you for the exam, at least in my opinion. I think the questions will help prepare you for the exam. And I'd like to go ahead and take a look at yesterday's top performers. So let's go ahead and switch to that. Okay, here we go. Our 18 people participated in the Kahoot. We have Kayla as the top finisher. Congratulations to you, Kayla. You did a great job. Followed closely by Melissa, Julia. Sung is at number 4. We have Akil at 5. Maria, Ali, Brianna, Amy, and Carolyn M is rounding out the top 10. Thank you for participating in this. You can go back and participate in this Kahoot again if you want to see the questions, if you want to practice. The Kahoots are for your fun and for your training. So have fun and take care and enjoy those Kahoots if you want. Okay, now got a couple of announcements really quickly. Let's go to the whiteboard. Okay, I'm not speaking in, you're not hearing double, I hope now. I hope there's no echo. I always seem to have an echo when I switch to my whiteboard. Don't forget, we will have finished the first 4 chapters, so exam 1 is this weekend. The exam is going to open Friday morning at 9 a.m., and the exam will be due Sunday at 11:59 p.m. It's 50 questions, multiple choice matching, true, false, ordering questions, and some 2 short answer questions that I think account for about 10% of the exam. You have 1 hour to take this exam. Please do not use your books or notes. You are supposed to take this book without resources. The exam will open Friday morning at 9 a.m. and it is due at 11:59 p.m. I'm going to have a review for the exam Friday at 9 p.m. live on YouTube. Usually I'll do the exams Friday afternoon, but I am umpiring Friday afternoon. I love baseball and I love to umpire, so I'm going to be working Friday afternoon, so I can't have the YouTube review Friday afternoon. So we're going to do it Friday at 9 p.m. Hope that's not too late. It's going to be live on YouTube, and you can find the link in the exams folder. So all you have to do is go to your exams folder or your lessons folder. You'll notice at the top of your lessons folder, there is the exam folder. Click on that link and you will see the exam 1 review live stream. Just click on that about 8:59 on Friday evening, and and you can participate in the review for the exam. The review is not mandatory. It's completely up to you, but I'd love to have you. You can come in and ask questions. We'll work on some things that'll help prepare you for the exam, and hopefully it'll help improve your grade. Any questions this morning? I see that Asada has come in. Good morning to you, Asada. Hi, Rand. I realize now that you don't want the D on that either. You just want the RAN. So I will note that in my mind. Any questions? If there are no questions, let's go ahead and get started on today's lecture. Chapter 4, Developmental Psychology. If you remember the first week of class, I told you that developmental psychology was an area of a subfield in psychology, an area of subspecialization where you could actually get a PhD. So you can get a PhD that says you that says you are a PhD of developmental psychology. And developmental psychologists are interested in studying how human beings change over the lifespan, from conception until death. So what we're going to cover today is we're going to talk about why the developmental perspective is important. Then we're going to talk about measuring milestones to make sure that your baby's development is healthy. We're going to talk specifically about language and language milestones a little bit. And then I'm going to introduce you to the first major theory of cognitive development created by a fellow named Jean Piaget, a Swiss psychologist, almost 100 years ago. That's a good question, Ebony. I was going to do it Thursday night, but I have webinar on Thursday night. So I thought doing a webinar and a review session on Thursday night would be too much. We can go ahead and take a vote in this class. Since you folks are here, you're the ones that care about these live events. Would you folks rather come to the review session on Thursday afternoon or Thursday evening rather than Friday? Would it help you to do it Thursday rather than Friday? Go ahead and take a vote in the chat bar. And if most of you would prefer to have it on Thursday, I'll move the review session to Thursday. Timing is always kind of odd and strange. And I'm trying to figure out the best timing for my classes. Friday, Thursday, Friday, Thursday. Oh, great. I'm glad to see that there's a definite preference. Thursday. Crap. Thursday afternoon or Thursday evening? Thursday afternoon or Thursday evening? Okay, I'm sorry to those of you who are saying Friday, but it looks like Thursday is carrying the day. I'd rather not do Thursday evening at 9 p.m. because I have class from 8 to 9, and I feel like that is a little bit of overkill. Either works for you. Oh, come on, give me a vote, folks. Thursday afternoon or Thursday evening? I was thinking maybe Thursday afternoon around 2 p.m. No, I have class at 1 p.m. Crud. I have class at 9 a.m. We have a webinar at 1 p.m. and we have a webinar at 8 p.m. Okay, I tell you what, we're going to go at 4 p.m. on Thursday afternoon. And Izada, I am super duper sorry that doesn't work for you. I really apologize, Izada, and those of you that wanted Friday. Let's go ahead and move that to Thursday, okay? So the review session will be Thursday at 4 p.m. All right, great. Let's go ahead and get back to the lecture and get started. We've got a lot to cover today. Lifespan development. Yes, it will be on Blackboard. As a Coral wants to know if it'll be on Blackboard. Yes, it will. It's in your exam folder, and it will be available as a recording as well as a live performance. So you can come at 4 p.m. and participate. If you can't make it Thursday at 4 p.m., you are more than welcome to watch the recording. It's one of the reasons I like to use YouTube for my class activities, because it creates an automatic recording while I'm doing it live, and it's just very convenient for everybody. I apologize, Ashley N. You've been very good about communicating with me this semester, and you've been very engaged, and I hate it that I'm not going to fit your schedule, Ashley, but I'll do the best I can. Now, why do we care about lifespan development? Well, you know what? You can think of human beings as a crop. And just like any other crop of vegetables or whatever you might grow, the better you support that crop, the more that crop is going to grow and produce fruits and food for you. So learning about human conditions allows us to know what humans need to thrive and grow in a healthy manner. So developmental psychology has really helped us improve the quality of the productivity and quality of human life. Now, I don't know if you know this, but did you know that the average lifespan has changed greatly in the last 120 years? Average lifespan is the age at which 50% of your colleagues will be dead. So if the average lifespan is 47, as it was in 1900, that means that 50% of us born in a certain year will be dead by the age of 47. Can you imagine that? Half of the population dead by the age of 47. Today, right now, the average lifespan is 79. Half of us will live to be at least 79 years of age. Now, that's occurred because infant mortality is relatively low. We learn the conditions to help babies survive during that very difficult and dangerous first year. And 15% of our population is older than 65, which did not used to be the case in 1900. And you know what some people say with the advances in modern medicine and what we know about health and healthy behaviors, that the average lifespan in some parts of the world in 2030 will be 90. Half of us, at least half of us, will live to be 90 years of age. And so learning about how humans develop and grow has allowed us to really create the conditions for healthy growth and long lives. All right, so developmental psychology is very important. Lifespan development isn't just studied by psychologists. It actually turns out that it's a multidisciplinary study of how people change over the course of the lifespan from conception to death. Doctors, sociologists, even anthropologists are interested in human development just like psychologists are. Now, since this is a psychology course, we're going to focus on developmental psychology from the psychological perspective. But I do want you to know that lots of different types of scientists are interested in human development. Now, oh my goodness, typically when we talk about human development and growth, there are two forces that cause humans to grow and change. The first is nature, and the second is nurture. You folks have probably heard of the nature versus nurture debate. It used to be people argued about whether or not humans were a product of their nature or their nurture. But now we know, and I want you to know, that humans are products of both nature and nurture. Okay? In fact, some people like to say that it's your nurture through your nature. So your nature sort of sets the basic blueprint of how you are going to develop as a human being, and your nurture is kind of like the artist that paints the final picture based upon the roadmap that your nature gives you. Nature, when we talk about nature, what we're talking about is genetically programmed maturation. Your genes and how they cause you to grow and change as you get older. And then a certain amount of development is dependent upon nurture, the environmental experiences that change you and cause you to evolve and development. Now, studying the human being is very complex because we have lots of different qualities. Are you going to study biological development? Are you going to study how people change physically? Are you going to study how people change mentally, intellectually? Or are you going to study how people's personality changes? Well, it turns out that scientists like to break down the study of human being and human change into three broad categories. There's physical change, which talks about how our brain and body evolves, okay? And then there's the cognitive sphere. How do our intellectual abilities change? And then developmental psychologists are also interested in how human beings' personality develops as we grow older. Now, you've probably noticed this maybe when you were in elementary school. Some of the kids in your class were way taller and more developed than other kids. I remember we had a boy in middle school that had a full beard by the age of 14. He was very far along the physical development line compared to the rest of us. Some people, you probably noticed in third and fourth grade, were very much intellectually developed, and they were way ahead of the rest of the class intellectually. Now, you might have noticed in fourth and fifth grade, some of your colleagues were very mature, and others were very, very immature. And the thing is, one person probably didn't have all three of those. So you probably didn't have the person who was taller, more intellectually developed, and also more socially mature than the rest of the class. Probably each and every one of you was on a different trajectory level with each of these three domains of human development. So we break down the study of humans into these three broad categories. And when we are evaluating how human beings develop, we typically evaluate them on these three dimensions independently. If any of you have children that have grown up and you've taken them to the doctor tends to evaluate your child on each, makes independent evaluations of your child on each of these three domains. And so what we're going to do today is we're going to talk about physical development and we're going to talk about cognitive development. And on Thursday, we're going to talk all about personality development, and I'm going to introduce you to the theory of Erik Erikson, who is going to be very important for all of you nursing students. So we're going to talk about that tomorrow. All right, so let's go ahead and get started. Development begins before birth. One of the things that is probably more biological than psychological is prenatal development, but it's prenatal development is covered in all developmental psych text and all introductory psych text. So I'd like to spend a minute talking about prenatal development. The process of change and growth starts even before you're born, when you are conceived in your mama's belly. Okay? And one of the ways in which you can start a healthy or an unhealthy life is by what happens inside your mom as you're developing. So what I want to talk a little bit today is teratogens, which are the harmful substances that sometimes mothers ingest that can damage a developing baby. So the first way you can make your baby healthy is by being careful with what you put in your body while you're pregnant. Now, you've all heard that there are some things you shouldn't eat or drink or smoke while you're developing, but you probably don't know exactly why this matters. This is what I'm going to talk about for a couple of minutes. First, let's talk about how human beings develop. And when you are conceived, and for the 40 weeks until you are born, you go through three broad stages of development in your mom's belly. And each of these stages is characterized by different types of things that are happening. So let's talk about them. You have the germinal period, the embryonic period, and the fetal period. When the egg is fertilized by the sperm, this fertilized cell called a zygote is in what's known as the germinal period. And this is the first 2 weeks of life when fertilization and implantation in the uterine wall occurs. This lasts for the first 2 weeks of pregnancy. And the most likely occurrence during this stage is a miscarriage. So the most likely bad thing that could happen is that somehow or another this zygote is not fertilized properly, doesn't implant in the uterine wall, and the damage that can happen if you're taking a teratogen or a noxious substance is that the baby can be miscarried and just not begin development. Now, starting around the age of 2 weeks, this little ball of cells, now called a blastula, is going to start folding in on itself, and it's going to create a little groove along the back of this ball of cells. And this neural groove is the beginning of the spinal cord and brain and the nervous system. And that starts about 2 weeks of development. So your brain actually starts developing 2 weeks after you're conceived. Now, it turns out that your brain's going to take 25 years to completely finish, but it begins here in the second week. In the development of the neural tube kind of signifies that the baby has moved into the second prenatal stage called the embryonic period. Now, the most important thing that happens during this period is what we call organogenesis. From 3 to 8 weeks, all of the parts of the baby are going to begin developing. The heart, the kidneys, the arms, the legs, the ears, the hearing, the lungs, all of your organs are going to begin developing. And if you look at this picture right underneath me, it sort of gives you an idea of this particular process. So if you look from 3 weeks to 40 weeks along this chart, what you're going to notice is that all of the systems are represented here by bars that run from where they begin to where they are finally fully developed. You'll see that. So your central nervous system begins first, your heart comes after that, then your arms, your eyes, your legs, your teeth, and all of these systems begin developing. Some start right at 2 weeks, some take as long as 6 or 7 weeks to begin developing. Now, what you'll notice about each of these bars is they have a green part and a purple part, right? Now, the green part represents when this system is most sensitive to teratogenic substances or environmental substances that harm a developing baby. Now, if the baby is exposed, now what determines the effect of a teratogen or a harmful substance on the baby? Well, it depends. It depends on the amount of the substance or the dose. It depends on the genetic susceptibility of the baby. And it depends on when that harmful substance is ingested. Now, when the system is in the green part, the developing system is in the green part, it's even more susceptible to damage from these teratogenic substances. Damage during this teratogens during the green part will actually disrupt the structural development of the organ. It won't even develop properly. If you take the teratogenic substances during the purple period, typically the structure of the organ won't be affected, but the functioning of the organ won't develop properly. There may be difficulties and there may be problems with how that organ functions. Back in the 1960s, there was a drug called thalidomide that was given to British mothers for about 6 months as a medicine for morning sickness. It turns out that this chemical was horribly teratogenic. And when these mothers took this teratogen, it actually caused organs to stop developing. So for several months, babies were born with half an arm, maybe half of their arm would develop, and then it would stop and be a nub. Or some babies developed with hands. They didn't have arms. Instead, they had hands coming right out of their shoulders. Or they might develop arms and hands, but they would only develop 1 or 2 fingers on these hands. So this teratogenic substance, because the baby was exposed to it during the very sensitive part of the development of these body parts, the body part just was structurally malformed. Now, it's not good ever to take a teratogenic substance while your baby's in the womb, but taking it at certain times will cause structural damage as opposed to other times where it will cause functional damage. Now, you folks know all the things that are bad for your babies. Nicotine, drugs, and alcohol use are teratogenic drugs. Some acne medication, lead, other types of chemicals can harm a developing baby. And I'm not really going to ask you to know all of those for the exam, but I do want you to know that nicotine, drug, and alcohol use are all associated with low birth weight. That is, being born at less than 5.5 pounds. Now, why does this matter? Well, low birth weight babies tend to have poorer outcomes than non-low birth weight babies. So what are some of the problems associated with low birth weight? Breathing problems, heart disease, other medical conditions. And you know what? Sometimes and low birth weight babies are at a higher risk for developmental delays and intellectual disabilities. Now, this doesn't mean that all babies who are low birth weight are going to be like this, but the risk of it happening is higher for these babies. So one of the things that we've done to increase the lifespan is to prevent babies from, is to understand that low birth weight, what causes low birth weight babies and the implications of being a low birth weight baby. This allows doctors to treat pregnant moms in such a way that pregnant moms develop healthier and have healthier babies. Any questions on prenatal development? I know I didn't spend a lot of time. If you take my Psychology 241 developmental psych class, we'll spend a whole day talking about prenatal development, and we'll go into more detail about the important facts regarding prenatal development. But I just wanted you to know that the story starts there, and that's where your baby can either be born, can have a healthy start or an unhealthy start. How many of you have children right now? I know some of you may have children. If you would, go ahead and type in the chat bar and let me know. Okay? I've got 2 children, by the way. They're a 20-year-old and a 21-year-old. And I am so glad they are finally grown and adults now. Now, let's talk a little bit about learning and maturation. I mentioned that on the first slide. What exactly occurs when your brain matures or when you learn? Oh yeah, I forgot. Noelia has a couple of children. We've already talked about this. I'm sorry, I forgot Noelia. Now, let's talk about what happens neurologically, because the changes that occur to you must somehow be represented in your neural tissue. And so let's talk about these 2 changes. I'm going to go ahead and start with maturation. Even though I've got it on the bottom, I'm going to start with it first. This is the programmed genetic change that occurs in your brain. And this is the growth and maturation after you're born, typically is in the changes that are related to maturation, is related to the growth of myelin tissue around your axons. If you remember from chapter 2, what we suggested is that myelin tissue is a fatty substance that grows around the axons of your neurons and makes them work very efficiently and helps whatever brain part is being myelinated mature. One of the things you'll notice about humans relative to a lot of other animals is humans are incredibly helpless at birth and for the first several years of life. This is related to the lack of myelin tissue in your brain. Now, the human brain is your competitive advantage as a human being. Humans don't fly. We can't run very fast. We're actually quite weak compared to a lot of other animals. We can't see at night. And so there are a lot of reasons why human beings are actually a very weak animal. But the reason that we rule the animal kingdom is because of our huge, complex brain. Now, the problem with having a big brain is if the brain is too big, the baby can't pass through the birth canal. So the baby has to be born with less than a full brain in order for the baby to be able to pass through the birth canal. Now, all the neurons you'll ever need are present at birth, and all the brain structures that you're ever going to need, localized areas of function, are there at birth. So what's missing from the brain at birth? Well, what's missing is the fatty tissue that surrounds your axons. And this is the part that's going to develop during the first years of life and is going to make that head grow so big, okay? Now, since we don't have it at birth, we're not very helpful. We're not very functional. And in fact, newborn babies don't know how to eat. They don't really know how to use their eyes. They don't know how to use their arms or legs. They can't sit up or roll over. they can't talk, they can't think, they can't really do a lot of things. Now, what happens is as this programmed myelination occurs, the areas that myelinate begin to mature. So after about the first 4 to 5 months, your baby's arms are neural pathways for arms are going to begin to mature, and the baby's going to be able to grab and hold things. As the neural pathways for the legs, for controlling the legs, begin to mature in the brain, the child is going to start taking their first step. As the myelination and the impulse control part of the brain begins to mature around 5 or 6, the developing child is going to be able to sit down and pay attention for a few minutes. So as all of these different brain parts begin to myelinate, the areas that they control begin to mature. Now, some parts of the brain myelinate earlier than others, and if you look below me, what you're going to see is sort of a picture of how this development occurs temporally. What you're going to notice is your occipital lobe matures first. That's responsible for your vision. Your motor and sensory cortex right here in the middle are going to mature relatively quickly too. And the child's going to be able to sense and move their body, right? What you're going to notice is that the parietal lobe, the critical thinking part of the brain, the temporal lobe for memory, and the frontal lobe for impulse control are going to myelinate more slowly than the other parts of the brain. So children are going to learn to walk and talk and understand their senses and see things much earlier than their memory, their impulse control, or their ability to think abstractly will develop. Does that make sense? And this is all dependent on a maturational process called myelination. In fact, those of you who have children, or if you might be pregnant now, they tell you although we typically say drink 2% milk because it has less fat, most doctors recommend that you give your children whole milk for the first 2 years of life because the extra fat content is useful in helping the child develop that fatty myelin tissue that develops around their axons. So maturation is an important part of the process of change and development that human beings go through. It turns out that your brain doesn't finish myelinating until 25 years of age. Can you imagine that? Those of you who are 21, your brain is not done. And really, what's going to not finish myelinating till the 25th year is this area for impulse control and planning. So most of you 18-year-olds might be a little more impulsive. You don't think about the future as much as old guys like me. And you may be more impetuous in your behaviors and make bad decisions. And the reason you do that is because your brain, the part of your brain that thinks about future consequences, isn't fully finished until you're 25 years of age. Okay, now the second change that occurs in brains, we typically talk about the second developmental change is called learning. What happens when we learn? Well, when we learn, we make more dendritic connections. If you'll remember in chapter 2, I told you that brains have dendrites and they're connected, almost connected to these terminal buttons. And so neurons communicate to one another between a terminal button and a dendrite. So dendrites are the part of your neuron that are receptive to chemical messages from other neurons. When you communicate, when your brain communicates to different parts of your body, one neuron communicates to another by sending a chemical message to that brain's dendrite. Okay? Now, what happens as we grow and develop? As we are stimulated, as the brain is stimulated, these little synapses, the connections between dendrites and terminal buttons, the connections between neurons begin to grow. And there's this process referred to by developmental psychologists as blooming and pruning. So what happens when you use a part of the brain is that part of the brain grows dendritic connections. It grows more dendritic connections than you will possibly need. We call this exuberant dendritic growth. So when you stimulate a neural pathway as an infant or a young child, that pathway is going to grow lots and lots of dendritic connections. And this is an overexuberance of dendritic connections. Now, what happens is, as that area begins to mature, your brain finds that one or several of these neural connections is the most effective way to communicate for that body part. And so the brain is going to start using that one neural pathway with those dendritic connections. And it's not going to use some of the other dendritic connections that were developed. So these unused dendritic connections are actually going to die off, okay? Because these dendritic connections aren't stimulated, they're just going to start to atrophy and die. So what happens in the brain is there's this process of blooming of connections among the neurons, and then there is a programmed neural dendritic death that pares down these synaptic connections. And what happens is, as the brain begins to mature, it creates the best neural pathways to control the different parts of your body. I would be writing down as much of this as possible. I've tried to, but ask the question, should you be writing down as much of this as possible? Generally, taking notes is a good student ability. Since this is an online class and some of the students choose not to watch the lecture, I have tried to make the charts a little more meaty than normal. So I've got more information on these PowerPoints, so you might not even need to write all of this stuff down. Okay, now, one term I want to introduce to you is this thing called a critical period. The brain and human beings go through many critical periods where the brain, part of the brain, will need stimulation in order for that ability to develop normally. I don't know if you knew this, but there is a critical period for vision in the first couple of months of life. You have to have your vision stimulated, your eyes stimulated, and your occipital lobe stimulated for your vision to develop normally. There is a language critical period where you have to hear. Everyone can learn a language, but only if you hear it, if you begin being exposed to a language within the first several years of life. There are case study examples of children who were brought up in a neglectful environment and weren't exposed to language until 5 or 6 and 7 years of age, and these children never develop normal language abilities. So the brain needs stimulation in different parts at different times in order for your abilities to grow normally. And in fact, why does that happen? Why can't you just grow an ability at any time through stimulation? Well, it turns out that your brain has a quality called neuroplasticity, which allows your brain to rewire itself in case you're born without part of your brain, or in case part of your brain becomes damaged early in life. So, if you remember, as I suggested, when you stimulate a brain, it grows dendritic connections. Well, if you're born without a part of your brain, that part of the brain will actually move, or the function controlled by that part of brain will actually be taken over by a different part of your brain. So if your brain is damaged, your brain can rewire itself. I don't know if you folks, let's see, I remember there's actually, I think it's in chapter 4, we have the study, I've got the case study of Ben Underwood, the blind boy who can see with his ears. Check this out. He was born and developed cancer in his eyes as an infant, and his mother had to make the choice to have his eyes removed at the age of 3. His eyes were removed so he could no longer see, but his occipital lobe and his visual association cortex areas were really, really young, and they were looking for stimulation. So what happened was his occipital lobe invaded the areas in his occipital lobe, invaded the auditory association areas, and he actually learned to see with his ears by using echolocation. So just like dolphins and radars, he learned to form a mental picture from the way sounds bounced off the objects in his environment. And by the age of 12, Ben could ride a bike, play basketball, run up and down the stairs because his ears allowed him to form a visual image. This occurred because of neuroplasticity. His brain rewired itself to account for the missing body part. Ala asked the question. So synaptic blooming is when there's successful dendritic connections without dying. Blooming is the dendritic connections growth, and that occurs in different areas of the brain. So blooming refers just to the growth. The pruning refers to the selective death of dendritic connections, Ala. So when you begin to learn a language, the Broca's area and Wernicke's area begin to knit together, and you get more neural connections than you will need. That's called blooming. That's called dendritic blooming. And then after that behavior begins to mature, your brain's going to find that it uses only some of those neural connections, and the other neural connections aren't useful. Then the process of pruning occurs. I hope that makes sense to you, Ala. Okay, now here's the thing. We cannot see the dendritic blooming and pruning and the myelination that occurs in the brain. Actually, you can use brain imaging techniques to see the development of myelin tissue, but it's incredibly expensive and your insurance company doesn't want to pay for that. So is there a way we can make guesses about whether or not your nervous system is developing normally? Yes, there is. And the idea is the use of milestone behaviors. Now, a milestone, it turns out this fellow named Arnold Giselle back in the 1930s came upon the insight that children, no matter where they are in the world, tend to develop along the same pattern with their abilities developing at the same time. So no matter where you grow up in the world, you're going to start walking and talking around the age of 1. Your arms are going to begin to develop before you're going to be able to use your arms before you're able to use your legs. You're going to be able to sit up before you're able to stand up and walk. And Arnold Giselle realized that children have this unfolding of their abilities that happens in a pretty predictable time frame. And so he came upon the idea that we ought to use these emerging abilities as milestones or markers of healthy neural development. And so developmental scientists have discovered that there are milestone behaviors for our physical development, for our intellectual development, for our personality development, and even for our language development, which are all abilities that are controlled by our nervous system. So what you do is you watch these milestone behaviors, and if they don't emerge at the appropriate time, this gives doctors a clue that you have some neurological developmental problems. Does that make sense? So milestones allow us to ask the question, is my baby developing healthy? So the early identification of developmental delays is very key to successful intervention. Remember I talked about brain plasticity? Brains are more plastic the younger you are. So the quicker you can find a problem like autism or some sort of visual problem or some sort of motor problem, the earlier you discover that problem and begin the intervention, the better the baby's outcomes are going to be. So doctors are very interested in watching milestone behaviors. Now, Noelia, your doctor may or may not have given you a handout to fill out, a questionnaire to fill out about what your baby could do at 2 months, at 3 months, at 6 months, at 9 months. Or your doctor might have just done it a little more subtly by asking you to describe your baby at your well baby checkups. But your doctors are listening to hear you tell them that your baby is engaging in milestone behaviors at predictable times. Now, what milestone categories do doctors evaluate? They evaluate our motor abilities, our ability to move our body around. Now, we typically have two types of motor abilities. Gross motor abilities involve the big muscles, like our legs and our torso, right? Those are called gross motor abilities. And then abilities that develop later are controlled by small muscles, the muscles in our fingers, the muscles in our lips. And those are called fine motor behaviors. So Noelia is saying, yes, her baby's milestones were tracked. Very important for the doctors. Yep. And then they also track intellectual milestone abilities, we'll call cognitive milestone abilities, and then socio-emotional milestone behaviors, and then language. Now, I told you that language is a part of cognitive psychology, but thinking and language are actually two separate abilities. And you know what? Some people are born with damage to their verbal areas, and they grow up to be completely normal in functioning mentally, but they can't speak. On the other hand, you'll see some people with incredibly bad developmental delays. They may be retarded, they may have any kind of intellectual disabilities, but they still learn to talk normally. So we typically separate out language development from cognitive development in terms of milestone evaluation. Why do we care about socio-emotional milestones? It turns out that autism is a socio-emotional difficulty. It's difficulty reading and responding to social cues. And so by looking at the typical socio-emotional milestones that should be developing, we can identify autism even earlier than used to be possible. Did you know that children are not born with the ability to smile? Now, some children have what's known as a reflexive smile that will occur, but that's just a reflex movement of the mouth. Children don't actually develop the voluntary smile until around the age of 3 months of after birth. And so the development of a smile, of the voluntary smile, is a good predictor of healthy neurological development in the socio-emotional areas of the brain. Now, we develop these expectations by looking at tons and tons of children. But just like some of you are early to class and some of you are late to class, even though you're still normal students, children sometimes are going to be a little bit behind other students in meeting these milestone behaviors. So wow, Leela says that her 2.5-year-old can't talk. Have the doctors suggested any reason why, or are they not worried? Now, my nephew, got an infant, he's 40 now. When he was born, he had language delays as well, and the doctors were interested and concerned about that. But it turns out he was having lots of ear infections and he couldn't hear very well. And so at about the age of 18 months, they put tubes in his ears. His affections went away and he could hear better. And his language milestones quickly began to catch up and his language developed normally. I'm sorry to see that, Leela. And your nephew didn't talk until 3 or 3.5. See? And the abilities still develop normally. So even though we have milestone expectations of when behaviors should occur, really the doctor is going to look at these behaviors and sort of make judgment calls about whether or not your baby's developing normally. Your baby was born at 23 weeks. All right, so he was a preterm baby and probably low birth weight as well, or small for age. And so having a baby born early can sometimes lead to these developmental problems. I am super duper sorry, Layla. I hope everything turns out well for your baby. Okay. Now, typically with milestone behaviors, the doctors are looking for your baby to do what 90% of to achieve behaviors at the same time that 90% of other children achieve those behaviors. If your baby's running a month behind on all their milestones, that's fine. As long as your baby is progressing through your milestones, the doctor is not going to be too concerned. What's going to concern the doctor is when your baby's milestone development achievement just stops. So your baby hits all their motor milestones for the first 6 months, and then just their milestone achievement just stops at 6 months and doesn't get any better. That's a clue to the doctor that something's wrong. Or sometimes babies will begin hitting milestones and then they'll begin losing milestone behaviors. And that's even more concerning to the doctor as well. Okay, so just because your child's not quite meeting milestones, it's a clue, but it's not the final word on whether or not your baby's neurological development is healthy or unhealthy. Any questions? So milestones and prenatal development. So watching what we ingest in our body during prenatal development and evaluating milestone behaviors are two ways in which we evaluate the health and quality of our young developing children. I don't know if you knew this, but the most dangerous time for a baby is during the first year of life. If you look at survival curves, what you will find is that you are more likely to die during the first year of life than you are for the next 30 years of life. And it's because children are sometimes born with birth defects or have these other congenital problems that cause them to die early in the first year. And so it's very important that we evaluate and pay attention to children during this particular period. Oh my God, it is 9:50 and I have not even gotten to Piaget. So I'm going to hurry up and talk a little bit about language development. It turns out the doctors say that there's an innate potential to learn language if exposed early in life. Now, there's not actually a brain part called the language acquisition device. This really refers to an innate potential to adopt a language. Children can easily learn a language without formal education as long as they are presented a language within the first couple of years of life. Now, there's a critical period for language. If your brain is not stimulated by hearing language within the first 5-6 years of life, your baby may not develop a normal language abilities. There's actually a famous case study of a girl named Jeannie Wiley who grew up with a crazy abusive father in California in the 1960s. He actually took this baby, locked her in a room, and wouldn't permit anyone to talk to this girl for the first 11 years of her life. They chained her to her crib and they would feed her through the door during the day and did not let anybody interact with her. And so when social services found her at the age of 11, she grunted and barked. She could not talk. And so after she was rescued, social workers tried to teach her how to speak. And Jeannie never learned how to speak, because she had missed her critical period. Now, what are the milestones that we will see in language during the first several years of life? If you look over here on this chart right below me, we're going to talk about the language milestones. Typically, babies are going to start, yes, it was evil, right? Typically, babies are going to start out by cooing, just making cute little gurgling sounds the first couple of months of their life. And then probably about 4 months of age, 5 months of age, children are going to start babbling. They're going to start using their lips and going ba 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 da 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 da, and they're basically practicing their phonemes, which are the sounds that are used in their language. It turns out that babies are born with the ability to hear all the sounds in every language. Now, I notice some of you are Middle Eastern, and you probably know there are sounds in Arabic and Hebrew that are not made in the English language. There are sounds that are made in Spanish that are not made in the English language. There are sounds that are unique to every language. It turns out that your baby, at about the age of 9 months, becomes deaf to the sounds that are not used, sound differences that are not used in their language. They move from being generalized, universal linguists to specialized linguists. So by hearing Arabic for the first 9 months of its life, your baby is going to become used to hearing the different sounds that people who speak Arabic use. My children who were brought up in an English-speaking household became used to the languages that are used in the English language. And in fact, if you've ever seen somebody try to learn a language as an adult, you'll notice that they sometimes have trouble mispronouncing words and can't say that, and they don't sound right when they say them. This is because that person's brain is actually not programmed to hear those important sound differences. And so making the sounds of language is the first milestone that you will see with babies. Holy cow, Etta Swider, one of my former students, has come in to say hello. Hello, Etta. I hope you're having fun up in Ohio right now. So that's the first milestone. Now, probably the second milestone is going to be the first word, sometime around 12 months. It's not all babies speak at 12 months. And Layla and Noella, your children are prime examples of children who maybe didn't hit this milestone. And Noelia, your baby, you said turned out to speak completely normally. And Layla, I hope your baby does too. The first word's typically going to occur around 12 months. Now, right after that, your child is then going to start around a year and a half. Your child's going to start putting two words together to make sentences. This is called telegraphic speech. Stuff like doggy bark, want cookies, it's me scared. Not real sentences, but they're going to be language utterances that convey meaning. The telegraphic speech. And then between 18 to 24 months, your child's language abilities are suddenly going to explode and become almost normal. And so your kid's going to just have this incredible explosion in the size of their vocabulary. This is called the vocabulary explosion. Yes, it is, Etta. Etta has a very good point there. This is the most useful class you will take in college. So children experience a vocabulary explosion during the second half of the second year. And then the last thing your child is going to develop around 3 to 5 years of age is the practical knowledge of conversation. How to have a conversation where you talk and listen, where you keep on task, you know how to talk about something without changing the subject, keeping a conversation on topic, adjusting your language to the ability of your conversational partner, your ability to read nonverbal signals, and most importantly, knowing what not to say, right? So I remember when my 3-year-old and I were in the grocery store, and he pointed at an adult's birthmark. This person in the grocery store line had this big, ugly birthmark on their face. And my little son said out loud, "Oh, look at that weird-looking thing on that man's face." And I was totally embarrassed because I was looking at it too, but I knew that you weren't supposed to say that. So my child didn't understand the pragmatic aspects of language, what you could and what you couldn't say. Thank you very much, Ada. Okay, so that's sort of the language milestone. So language is one example of how milestones develop over the first several years of life. I totally did not get around to talking about cognitive development. It is very important, and I'm going to find a way to talk about it tomorrow in class. So we will pick up this lecture tomorrow morning at 9 a.m. I'm sorry we've run out of time. Thanks to everybody who came to class. Etta, thank you for stopping in and saying hello. Thanks to everybody who participated. I liked hearing about your children and your interests, and thanks for being engaged today. Does anybody have any questions before I log off? Anybody have any problems, things they'd like to talk about? I'm going to go ahead and look in the chat bar. If we don't have any questions, I'm going to go ahead and log off and say goodbye. It's been great seeing you, Gid. Thank you for 18 of you coming in today. I appreciate your engagement and your participation in this class. You are a great set of students. Take care, and I will see you oh, wait a minute. What about children who are nonverbal? Do they have different milestones? What do you mean by nonverbal? You mean kids that can't speak? I'm not exactly what you mean by that. Go ahead and ask that question, and I'll respond to you through the chat bar later, Coral. Otherwise, take care, folks. Have a great day.